Bismillahirrahmanirrahim. Assalamu alaikum students. I am your physics teacher and I will teach you physics as I have done in 9th class. In 10th class you have a bulky syllabus as compared to the 9th class. As you know, in 9th class half of the syllabus we have finished in 8th class and rest of that we have finished in the 9th. But in 10th class I need your full attention and cooperation, more cooperation, because you have to finish the whole of the book in 1 year and then we have to revise the syllabus. So I will suggest you or I will advise you that please be with me with every lecture and do learn it with the every lecture, at the finish of the every lecture, so that we have a time to revise the book. Okay, so this book contains 9 chapters. First chapter is about simple harmonic motion and waves, and we will start from this chapter. Second chapter further about the types of waves, means sound. Third chapter is also about the waves, that is geometrical optics, in which we study light waves. After that we have the fourth chapter, which is electrostatics. In electrostatics we will study the charges at rest. Okay, the fifth chapter is about the moving charges and its name is current electricity, in which we study the charges in motion, which is called current. Next chapter is about electromagnetism. In electromagnetism we will study about the magnetism, how the magnetism can be produced through electricity and magnetism separately. Next chapter is about basic electronics, and in this chapter we will study about some circuits and some main, or you can say the basic electronic devices or electronic circuits. 17th chapter is about information and communication technology, in which we will study about IT, as it is not the branch of physics. Purely we can say that it is not the branch of physics, but now it is the part of every scientific subject that you should know, or you should have somehow a little bit knowledge about the IT, so that you can cope, or you can bring IT, or you can bring your subject in the IT. Next and last chapter is about atomic and nuclear physics, and in which we will study the structure of atom and nucleus. Okay, so this is the review of your chapter, and now we are going to start from the first chapter, which is simple harmonic motion and waves. So simple harmonic motion and waves, I have shared the objectives of only this week. In this week, which topics we will be covered and what are the outcome of those topics. So in this week, in this chapter you will study about the simple harmonic motion, that what is that simple harmonic motion, and the necessary conditions for an object to oscillate the simple harmonic motion, then its important features and its some of its examples. The main example which is elaborated briefly in this chapter is mass attached to a spring system. So this is your main question, you can say the long question. Okay. After that, 2 other examples are being given, that is a simple pendulum and ball and bowl movement. And understand the damped oscillations. You will understand the concept of the damped oscillations, that what are the damped oscillations. So before going to the main topic, I have some questions to be asked from you people on the basis of your previous knowledge. And the first question is, what is an oscillation? So what is an oscillation? Now you can answer me on the basis of your previous knowledge which you have studied in 9th class. You will remember that we have studied about the types of motion. Okay? And in those types of motion you have heard the word oscillation. So what does oscillation means? Just remember in your mind, and then after that show the answer. Okay, so oscillation basically is the to and fro motion of a body about its mean position, and such type of motion is called oscillatory or vibratory motion. And the movement performed by the body is known as the oscillation. Second question is, what are the examples of oscillatory or vibratory motion? So it is it should be very simple for you, and the examples of these are, just remember in your mind and then see the answer: pendulum of a clock and seesaw. So simple harmonic motion is also a special case of vibratory motion, and in this chapter we are going to study basically the type of vibratory motion which is called as the simple harmonic motion, and you will study the characteristics and parameters of simple harmonic motion briefly in this chapter. So I guess now it should not be a difficult term or word, simple harmonic motion, to you people, because it is the type of vibratory motion just. Okay. So now to understand the simple harmonic motion or simple harmonic oscillator. What is simple harmonic oscillator? Any body or any object which performs simple harmonic motion is known as simple harmonic oscillator. So to understand the simple harmonic motion, its features, its characteristics, we are going to consider an example, and the example is of motion of mass attached to a spring system. So now we are going to study about this example, and this can come in your paper under a long question. ठीक है? So short में भी आ सकता है कुछ parts में, but the chances are that it can come in the long question portion. Okay, to understand a simple harmonic motion and its features, you have 3 examples in your book. One is mass attached to a spring system, and another 2 are simple pendulum and ball in a bowl, as I told you earlier. Now consider a spring, as you can show in this picture. This is a spring. Okay, one end of a spring is attached to a rigid support. This rigid support, just see the movement of the cursor. Okay, and the other end of the spring is attached with some mass. Okay, so this is our mass attached to a spring system. ये पूरा एक system हो गया. Now initially when no force is applied, that is F is equal to 0. ठीक है, when no force is applied on the spring is at its equilibrium position, or you can say spring is at rest. When it is in equilibrium position, we can mark some positions of the system. Like you can see the middle point of this mass, that is showing the mean position O. ठीक है, and A and B, these points A and B जो है, that are showing the 2 extreme positions. As simple harmonic motion is a special case of vibratory motion, and in vibratory motion, you know, body oscillate about its mean position, or body performs to and fro movement or back and forth movement. ठीक है, so these 3 positions are very important. So just what should I say? So let's just note down these 3 positions. Now in this figure, force is 0, x is 0, displacement. Now what is this displacement? This displacement is from mean position to any of the extreme position. Yani this displacement or this distance can be OA or OB. And by the way, OA and OB will be equal, but in the opposite directions. Okay, so just remember these parameters: force, displacement, mean position, and extreme positions. Okay, in the previous slide we have studied that when no force is applied, the spring is at its mean position. Now what happened if we will apply some force on it? If we apply some force F on the mass, like what we will just do, we'll hold the mass M in our hand and just stretch the spring towards east at some displacement, and then we will release it. When you will release it, what happened to the spring? You can see in this animation. Okay, in the animation you have seen that when we release the mass M, the spring start oscillating about its mean position from O to A, and then from A to O to B. ठीक है. And one complete vibration or one complete cycle is called one vibration, and one complete cycle is started from O, where we have just started displacing the mass m, then it goes to A, then back from A to O, then O to B, and then back from B to O. This is a one complete cycle or one complete vibration of this mass attached to a spring system. Now you must remember, I have told you earlier, mean position and the two extreme positions, which are A and B. Around these positions the spring is moving. ठीक है. Now we are going to determine the equation for simple harmonic motion. Okay, in this diagram you can see, before determining the equation for simple harmonic motion, just see this diagram. In this diagram you can see that in this figure the spring was at rest, no force was applied, but here we have applied some force F. After releasing the mass at extreme position A, the mass will move towards mean position O, ठीक है. And then from O to B, mass will not stop at O, but rather it should stop at O. But why it shouldn't stop while rather it moves towards D? The reason I will told you in the coming slides. But just see here that the object जो है object is covered the same distance towards the left side from the mean position. ठीक है. So this is the complete diagram of the simple harmonic motion which you have to drawn in this question. Okay, so now we are going to determine the equation for the simple harmonic motion. When we apply a force on the spring, it elongates or it covers some displacement. So now according to Hooke's law, which is about the elongation of the spring and which you have studied in the 9th class, applied force is directly proportional to the displacement x. Okay, applied force is directly proportional to the displacement x. By putting a constant we get the equation F is equal to minus kx. Here k is the constant of proportionality and it is called the spring constant, and its value depends upon the material of the spring or nature of the material from which spring is formed. Also the spring constant tells you about the stiffness of the spring, how a spring can be stretched. ठीक है. What does negative sign indicates? I'll tell you further. Okay, when F, according to Newton's law, we know. Okay, from here we can take out the value of k. K is equal to minus F by x. By cross multiplication you can get this equation. ठीक है. Now according to Newton's law we know F is equal to ma. So put this value F is equal to ma in this equation. ठीक है, in the above equation, and we get k is equal to minus ma over x. And from here if we take out the value of a, yani acceleration, so a will be equals to minus kx over m. So from here we can see that acceleration is directly proportional to x, as k and m are constants, but in the opposite direction. Negative, what negative sign shows? Negative sign shows that acceleration and displacement, or you can say force and displacement, are in the opposite direction. That's why we have a negative sign in this. Okay, so in the above equation you have seen that negative sign shows that the force is always opposite to the displacement. Okay, यानी force जो है that is directed towards the mean position, while the direction of displacement is towards the extreme position. Displacement is from O to A, while the force is from A to O, because we have released the body or we have released the mass at A and then it has started moving from A to O. So force is directed towards the mean position and the displacement is directed towards the extreme position. The same force, this force sometimes is called the restoring force, as it compels the mass to move from A to O, यानी अपनी इनिशियल पोजीशन को रिस्टोर करने के लिए मैस इनिशियली O पर था, तो जो फोर्स हमने लगाई है इसको हम रिस्टोरिंग फोर्स इसलिए कहते हैं बिकॉज इट कंपेल्स द ऑब्जेक्ट टू रिस्टोर इट्स प्रीवियस पोजीशन and it compels the object to move from A to O. That's why we call it restoring force. Okay, now here comes the definition, very important definition from the paper point of view. The definition of a restoring force: a restoring force always pushes or pulls the object performing oscillatory motion towards the mean position. This is the definition of the restoring force. Now in the next point, last point, we will explain the complete cycle or a complete vibration of a mass attached to a spring system. You can see that the from O we have applied a force from O and we have taken the mass at A. Okay? At A, when we come to our first extreme position A, we release the object, and due to the restoring force the object moves from A to O. Okay? From now moving from A to O, the speed of the body gradually increases, and at the mean position the speed of the body becomes maximum. यानी mean position के ऊपर body की speed maximum होगी, and from the mean position towards the extreme position it will go speedily, maximum speed के साथ ये move करेगा, while the displacement was maximum at A, and when the body reaches at the mean position O, its displacement will become 0. ठीक है? Now from O to B, why the body moves from O to B? Due to inertia. In 9th class you have studied that a body wants to retain its previous position. As the body was at A, so body wants that it will remain at the extreme position. So what it will do, it will go with the maximum speed from O to the another extreme position B due to inertia. And when it reached at B, from B again due to the restoring force it will start moving from B towards O mean position. So in this way one complete cycle of the mass attached to a spring system will be completed, and the process will repeat. Okay? And such type of motion is called as the simple harmonic motion. Okay, so the body will continue its back and forth movement about its mean position, and such type of motion is called simple harmonic motion or simple harmonic oscillator. The body which performs such kind of motion is called as simple harmonic oscillator. The time period, any time to complete one vibration or time to complete one oscillation, is known as the time period. So the time period of the mass attached to a spring system can be calculated by this equation: T is equal to 2 pi under root m over k, where m is the mass of the block which you have attached with the spring and k is the spring constant, which I have told you earlier. On the basis of the speed of the mass which I have discussed, we can determine the values of the energies of the mass on different positions. As the speed is maximum at mean position, so due to the speed, kinetic energy, which is half mv square, will be maximum at mean position, but it will be 0 at extreme positions A and B, because at A and B v or the speed of the object is 0. So kinetic energy will be maximum at mean position and 0 at the extreme positions, while the potential energy, which is due to the position of the body, will be maximum at extreme positions A and B, because at these extreme positions the displacement of the body is maximum. And you know potential energy is equal to mgh. H is the displacement which you can replace by x, mgx in this case. So potential energy will be maximum at extreme positions A and B, while the potential energy will be 0 at mean position, because displacement is 0 as at mean position. So these energy description is very important. This can become in the short question, so you have to understand these very well. So here is the topic. Your topic is complete here. Next two examples, mass, simple pendulum and ball in a ball system, we will discuss in the next lesson. Any question, you can ask me any questions in the WhatsApp group. If you are unable to understand something, then you can ask me surely.